How to measure the resolution of a light microscope? What is the point spread function? How to follow the evolution of the performance of a microscope lens in time? Here are some topics we'd like to throw light on with this video. To characterize properly a light microscope, we need a punctual light source. When this source is smaller than the theoretical resolution of our system, we acquire its point spread function. This will provide us valuable information on the health status and alignment of our optical system. We want to show you in this video how to prepare calibration samples, correctly acquire images, and perform simple data extraction to monitor your microscope performance in time using fluorescent beads. To prepare the sample, we are going to use the following items: fluorescent beads of different size depending on the microscope objective, a slide and a 1.5 type cover slide, a pipette, 5 to 10 microliters of mounting medium, 5 milliliters of dental silicone, we really prefer it to nail polish, with a petri dish, forceps, and some milliliters of distilled water. Which beads to choose for the characterization of our objective? Let's take as an example a 63x oil immersion objective 1.4 numerical aperture. For a given wavelength of 525 nanometers, the midpoint of a typical green channel detection, the theoretical lateral resolution is 229 nanometers for a wide field microscope. The appropriate size of the beads here has to be lower than this value. So we will use beads of 170 nanometer diameter. To obtain a high signal-to-noise ratio, we choose monocolor beads. It's convenient to use multicolor beads because we can also measure chromatic aberration, but as their typical size is 200 nanometers, PSF measurement for high magnification objectives will be less precise. It all depends on what we want to monitor. Let's start by diluting the original bead suspension to a suitable concentration, around 10 to the power 9 beads per milliliter. The bead density is critical in order to find isolated beads in the center of the field of view of our microscope. We can vortex or even sonicate the bead solution to dissociate possible aggregates. Here we dilute the beads 300 times. Don't forget to clean the cover slide using Kimtech paper and 70% ethanol. Now we place a small amount of the bead solution on the cover slip, 5 drops or 5 to 10 microliters, and let it dry a few hours at room temperature. When all the liquid is evaporated, we put the cover slide on the slide using 5 to 10 microliters of mounting medium. We use dental silicone to seal the gap between the cover slide and the microscope slide. Dental silicone is chemically neutral and does not damage the system optics, unlike the more widely used nail polish. For long-time conservation, keep the slide stored in the fridge and protected from light. Before starting the acquisition, it can be useful to call back the notion of sampling rate. According to the Nyquist criterion, the voxel size should be 2 times lower than the microscope resolution. In our case, with a 63x objective of numerical aperture 1.4 and with a 525 nanometers wavelength, the lateral resolution is 229 nanometers and 536 nanometers for the z-axis. These values correspond to a 100 and 230 nanometers sampling rate, respectively. In wide field microscopy, the XY sampling rate depends on the camera pixel size and on the magnification of the optical system. We now place the slide on the microscope and look for the beads. Now, let's find the focal plane with the acquisition software. By avoiding binding, we make sure that the pixel size does not exceed 100 nanometers. We also check that the Z-step size does not exceed 230 nanometers. The stack should cover a range of a minimum of 5 times the axial resolution value, centered on the base focus plane. Choose the appropriate exposure time in order not to saturate the image. Now, let's start the acquisition. The easiest way to analyze the data is to use the Métrologie plugin on Images software. As you can see, the installation of the plugin is very easy. Once the Z-stack is open, it's important to check the calibration of the scale and ensure that the voxel size corresponds to the values of the sampling rate that we previously calculated. Pick one isolated bead, preferably not the brightest one to avoid aggregates, and preferably in the center of the field of view to prevent chromatic aberration. We crop or duplicate the region of interest and launch the Métrologie plugin. Choose wide field option, then fill in the wavelength, and then the numerical aperture. In our case, the pinhole value remains 1. Once we are done, we pick the destination folder to save the report file. The report document consists of 3 projections of the image stack in XY, XZ and YZ, information about the acquisition, a table presenting calculated values for the experimental and theoretical resolution, and the intensity profiles centered on the bead in X, Y, and Z. How do we interpret these results? First, the experimental value, that is the full width of alt maximum of X and Y profiles seen previously, should not be very different in X and Y direction. Experimental and theoretical values should be quite close. If the ratio between these two values exceeds a factor of 1.5, your lens probably needs to be checked. Second, the shape of the XZ and YZ projection is very important. We observe here a diffraction pattern that should be symmetric, and we should not obtain exotic shapes like arrow or banana-like form. These shapes are indicators of aberrations of the system, in that case spherical and coma respectively. Care should be taken to use the correct immersion and mounting medium, cover slip thickness, and work at the specified temperature. To increase statistical precision, this measurement should be carried out for at least 3 beads. What have we learned today? We have learned how to track optical microscope performance over time. Now, we advise you to keep the data. Create a table of the measured value with the date of the acquisition in order to track the microscope performance in time. Thanks for watching and enjoy Métrologie!